Hello, guys. I hope everyone is having a great week. So we're going to look at some practice problems together. So we're going to start graphing points on a coordinate plane. So this is a coordinate plane. I believe you have already started graphing points in quadrant 1. So when you only have positive numbers, usually you'll start probably in 5th grade, I guess, graphing points, maybe 2 positive numbers, right? For example, if you have 3, 2, this first number tells you to start at 0, 0, go to the right 3, 1, 2, 3, and from there you go up to 1, 2, and there would be the point called 3, 2. So now, since we started talking about positive and negative numbers, we're going to graph in all 4 quadrants, okay? So we got to talk about some vocabulary. So the first thing you need to recognize is that there are 2 axes that divide up our coordinate plane into 4 quadrants, okay? So you have a horizontal axis, which is always going to be called the x-axis. And usually they're labeled, not always, but usually. And then you have a vertical axis that goes up and down, and that is always labeled the y-axis. So you do need to know those 2 terms, the x-axis and the y-axis. You need to know that the x-axis is horizontal, goes left and right, and the y-axis is vertical, it goes up and down. All right, the next point you need to be able to identify is the origin. So it's where the 2 axes cross, and the coordinates of the origin is 0, 0. Okay, so if you move off from the origin, you're no longer at 0, 0, but every time you go to graph a point, you need to start at the origin at 0, 0. And then I talked about there are 4 quadrants. So they are named and they're numbered by Roman numerals. So this first quadrant is quadrant 1, and then we go counterclockwise. The second quadrant is right here, quadrant 2, and then down here would be quadrant 3, and finally this is quadrant 4. Now, there are, the way you move on a coordinate plane is by a set of ordered pairs. You can also call those ordered pairs coordinates. And then you can call, once they've been graphed, you can call those a particular place a point on a coordinate plane. Okay, so when you start a graph, you always start at the origin. Now, you always have 2 numbers that tell you what 2 directions to go. If the first number is positive, it tells you you're going to move right on the x-axis, you're going to move right. If the first number is negative, that means you start at the origin and you move left on the x-axis. And then you're going to have a comma to separate your 2 numbers. The second number, if it's positive, you're going to move up on the y-axis, or you're going to move down on the coordinate plane. Okay, so to get into quadrant 1, you have to have 2 positive numbers, because to start at the origin, you would have to go right and then you have to move up. So to get into quadrant 1, you would need 2 positive numbers. So to get in quadrant 2, you would start at the origin, go left and then up. So the first number, if it's negative, and then the second number is positive, that means you're going to end up in quadrant 2. The third quadrant, you start at the origin, you would have to go left and then down. So you would need 2 negative numbers to get into quadrant 3. And then finally, quadrant 4, to start at the origin, you would have to go right and then down. So that means the first number would have to be positive and the second number would have to be negative. Okay, so those are always going to be the way you get around your coordinate plane. So now let's try graphing these 4 points. So let me erase all this. You might want to write that down so you're taking notes and you can write that down. So if we have a positive number followed by a positive number, that means we're going to end up in quadrant 1. So you start at the origin, you're going to move right 1 and then up 4. 1, 2, 3, 4. And there's our point, and we would call that whatever, point A. The second one says we're going to go left, and then we're going to go up. That means we're going to end up in quadrant 2. So from the origin, we're going to go left 2, 1, 2, and then up 3, 1, 2, 3. And there is our point, and we'll call it point B. The third coordinate, we're going to go left 3 and then down 5, which means we're going to end up in quadrant 3. So we're going to go from here, left 3, and then down 5, way down here. We can call this quadrant, or excuse me, point C. And then finally, the last one says we're going to go right, and then we're going to go down. So we're going to end up in quadrant 4. So from the origin, we're going to go right 4 and then down 2. And we can call that point D. So now we have graphed points in all 4 quadrants. All right, now a reflection. So like if you get up in the morning, you look in a mirror, you are seeing your reflection. So let's say we start with a point like this point right here. So we'll call that point W. And we want to reflect it over the x-axis. So first thing you need to do is ask yourself, which of the 2 axes is the x-axis? So obviously it's this one, right? It's the horizontal axis. So if I reflect W over the x-axis, that means the x-axis is going to be equal distance between my first point and my second point. So if you start at the x-axis and think, okay, well, this is 2 above the x-axis. If I reflect over the x-axis, I'm going to be 2 below the x-axis. So my original coordinate for W was 4, 2, right? And when I reflect over the x-axis, that first x value stays the same because I'm still going right 4 on the x-axis, but then I go down 2. So now the reflection of W is at 4, -2. Okay, so when you reflect over the x-axis, the x coordinate, oops, that's not what I wanted to write. Oh, and I should have told you one thing. I should have told you that when you graph these 2 numbers, the first number always is a reflection of what you're doing on the x-axis. And so this order is always considered x comma y. This is the x coordinate and this is the y coordinate. This is the x coordinate and this is the y coordinate. And that doesn't change, okay? So when we reflect over the x-axis, the x coordinate, which is the first number, does not change. The y coordinate becomes the opposite of what it started out to be, of the original. All right, so let's talk about that again. So if W is at 4, 2, and I reflect it over the x-axis, that means we're still going right on the x-axis, and now we're going down 2. So now our new coordinate is 4, -2. So it was a +2, now it's a -2. That's what this means. The y coordinate becomes the opposite sign of the original, okay? All right, so what do you think happens when we reflect over the y-axis? So let's go right here. All right, so we'll call this point N. All right, what if we reflect this over the y-axis? Well, first of all, this is the y-axis. So you always head toward your line of reflection. So right now, if we're going toward our line of reflection, we are 4 units away from the y-axis. So if we reflect it, we still need to be 4 units away, but in the opposite direction. So now Our reflection of n, we can call it n prime, looks like a little apostrophe. It becomes 4, 1. The original coordinate was -4, 1. So what happens when you reflect over the y-axis? The y coordinate does not change. The x-axis, the x coordinate, is the opposite. Sine, oh my goodness, my writing is horrendous. Sine of its original. Y'all understand what I mean, okay? So make sure you're writing these down. Make sure you are taking notes of these because you're going to have questions over this stuff, okay? So we're talking about reflecting over the x-axis. You're going to go down or up if you're reflecting over the x-axis. If you're reflecting over the y-axis, you're going right or left. You always move toward your line of reflection. And this would be your lines of reflection. Okay, guys? All right, so you guys are going to practice that. All right, what else? So not always will you end up exactly in a quadrant. Sometimes you'll actually land on either the x-axis or the y-axis. So let's just review. The first number controls right and left. Okay, right and left. The second number controls up and down. This is our big set of parentheses for our ordered pair. So what if the first number is 0? That means do not go left or right. The second number tells us to go down 3, right? So start at the origin, do not go right or left because the first number is 0. Second number says go down 3. 1, 2, 3, and that's where I land. So we'll call this point A. And it's not in a quadrant, but it's on the y-axis. So where did we land? We landed on the y-axis. What is that? An A? I don't even know what that means. Oh my gosh. You guys, I don't pay attention to what my brain and my mouth don't communicate sometimes. So where do we land? We land on the y-axis. All right, let's look at the second one. The first number controls right or left. So don't go right or left, but then go up 4. Start at the origin. Don't go right or left, but go up 4. And we'll call that point B. And where did we land? We landed on the y-axis. All right, let's look at point C. It says, the first number says go right 2, and then the second number says don't go up or down, right? So we're going to start at the origin, we're going to go right 2, and then 0 says stop. So this is point C, and where did we land? We landed on the x-axis. And then point D says the first number tells us to go left 5 and then stop. Left 5, so start at the origin, go left 5, and then don't go up or down. So that is point D. And where did we land? We landed on the x-axis. Now also, you will occasionally have decimals or fractions to graph instead of whole numbers, okay? And so it's easy to figure out what to do. It's not too difficult. This means go left 1.5, 1.5, and then go up 3. So if we went 1 to the left, it puts us there. There's -2. So -1.5 has to be right in between -1 and -2. That makes sense. And then we still go up 3. So from here, we go straight up 1, 2, 3. And that would be point E. And where are we? We are in quadrant 2. This is point E. All right, this one says go right half a unit, and then go down 2.5 units. So start at the origin, go right half a unit right here. And then from here, we're going to go down 2.5. 1, 2.5, right there. And so we have to kind of eyeball it, but we should get pretty close, right? So we'll call this point F. And where did we land? We're in quadrant 4. All right, what about point G. We're going to go right 4. So from here we go right 4, and then we go up 2 and 3/4. So 3/4 is 0.75. So more than 2.5, but less than 3. Halfway between 2.5 and 3. So we're going to go right 4 up 2. There's probably about a half right there. So we'll put it right there. And yes, we are kind of eyeballing it. But that's just what you have to do. I think it went down a little bit. All right, so that's point G. And so we're in quadrant 1. And finally, this says go left 3.5 and down 4. So from here, we go left 3.5, down 4, right there. And we'll call that letter H. And in what quadrant are we? We are in quadrant 3. So you guys, hopefully you got all of that. You did all that with me. That's great. All right, now you sometimes will have to take information from a table, create coordinates, and then use those coordinates and graph those points, which you can do that, totally acceptable. All right, so it's saying that we are going to have ratios. So ratios are basically equivalent. If we made it a fraction, they would be equivalent fractions. So it says finish the table by finding the next multiples of the ratio. So if our first point is 4, when we would go up by 4, right? The next one would be 8, and then it would go up by 4, and the next one would be 12, and then it would go up by 4, and the last X coordinate is 16. And then this is going to be our Y coordinates. So if our first quantity is 2, we're going to go up by the next multiple. 2 times 2 is 4, 2 times 3 is 6, and 2 times 4 is 8. All right, so we have just completed this table by finding the next multiples. So now it says we're going to use this table and we're going to write a list of ordered pairs, also called coordinates. Those terms can be used interchangeably. So if you notice, I titled this X and this Y. So X is always going to be on the left, Y is always going to be on the right. And that's how we write our ordered pairs. We're going to write 4, 2. That's X, Y. Our second ordered pair is 8, 4. Our third ordered pair is 12, 6. And the third is 16, 8. All right, now what do we need to do? It says we're going to graph these points. So here, our X coordinate is the number that is in the first position. And remember, your X is always your horizontal axis, and this is going to be our Y. It's always your vertical axis. So this tells us to go 4 on the X-axis and then up 2. So from here we go 4. This represents 4 cups of flour and 2 cups of sugar. All right, then 8, we're going to go right 8 up 4 right here. That's for every 8 cups of flour, we need 4 cups of sugar. And then for every 12 cups of flour, we need 6 cups of sugar. And then 16 and 8. So we've just graphed all those points, and we could connect those dots if we want to, and it would be a straight line. All right, then it tells us to what? I've lost my mouse, you guys. Someone is texting me. All right, what is the unit rate of cups of flour per cups of sugar? So since flour goes on top, flour over sugar. So flour over sugar. So 4 over 2, 8 over 4, 12 over 6, 16 over 8. What do you guys notice about all of those fractions? They all simplify to 2. So it's 2 what? You got to put the words in order. 2 cups of flour per 1 cup of sugar. So you got to keep the words in the same order. So what's the unit rate? It's 2 cups of flour for every cup of sugar. That's for 1. Unit rate means for 1. okay? So 2 cups of flour for every cup of sugar. So now the question is, how many cups of flour would be needed if there were 7 cups of sugar? There were 7 cups of sugar. Well, here's our cups of sugar over here on the vertical axis, right? So cups of sugar is saying, what if there's 7? We want to know how many cups of flour. Well, if we did make this a straight line right here, if we connected these dots, y'all know I can't draw straight lines. Oh my goodness, that's terrible. See, I'm so bad at that. But anyway, this can give us a good idea. Look, if we go left right here, if it's on this spot right here, what's the answer? 14. I mean, you guys probably know the answer because you did it in your brain mathematically. What ratio equals 2? Well, it would have to be 14 over 7, right? But the graph can also help you answer that question as well. All righty. Now, one thing you're going to have to do this week is I'm going to give you a little practice sheet and you're going to have lots of points on it and you have to write the coordinates. So let's do those, a few of those right now. So what are the coordinates, or what is the ordered pair to get to A? Well, A is right there. So to get over there, I would go right 2 up 7. Right 2 up 7. How do I get to B? Well, I would go left 4 and then up 6. Make sure you're always going right or left first and then up or down. Letter D, I would go left and then down. So it would be -3, -3. And then letter E is up here. So do you remember how to get to that coordinate? The first number tells me to go right or left. Do I go right or left? No. So the first number is 0, but then I go up 2. And then finally, letter F, to get from to here, I would go right and then down. So I would go right 7 and down 5. So don't drop any of your negative signs. Okay, guys? All right, well, you guys work through these problems, and if you guys have any questions, let me know, and I'll be happy to help you. If we need to jump on Zoom and let me answer some of the questions that you might have, I'll be happy to do that. All right, guys, everyone have a great week.